Welcome to this presentation on system design for large-scale systems. Today we will be exploring the challenges and key considerations when building systems at scale like those used by Facebook and Google. Let's dive in. Here's the agenda for today's presentation. First, we will discuss the challenges of building systems at scale. Then we will dive into key design considerations for large-scale systems, followed by an example of how Facebook handles system design. Finally, we will conclude with some takeaways. Let's get started. Building systems at scale is no easy. We need to handle massive traffic loads, ensure data is distributed effectively across servers, and manage system consistency. We also have to think about fault tolerance to ensure that the system stays up and running even in the event of failures. Let's take a closer look at these challenges. First, let's discuss traffic handling and load balancing. When we are dealing with millions or even billions of users, it's crucial to distribute traffic evenly across multiple servers. Load balancing techniques such as round-robin, least connections, and weighted balancing are used to ensure that no single server is overwhelmed. Systems like Google and Facebook employ complex algorithms to manage their traffic effectively. Next, we have distributed data management. Large-scale systems must store data across multiple servers and data centers. This is achieved through techniques like sharding, which divides the data into smaller parts, and replication, which ensures multiple copies of data for reliability. Many modern systems use NoSQL databases like Cassandra to implement these strategies. Now let's talk about the CAP theorem. This theorem states that in a distributed system, you can only have two out of three qualities: consistency, availability, and partition tolerance. Most large-scale systems like Facebook and Google prioritize availability and partition tolerance, often sacrificing consistency for better user experience and uptime. Fault tolerance and high availability are critical in large-scale systems. We achieve fault tolerance through redundancy, keeping multiple copies of data across different servers. If one server fails, another can take over. This ensures that the system remains available even during hardware or network failures. Latency and performance are also key factors. Users expect real-time access to their data, so minimizing latency is essential. Techniques like caching using systems such as Redis or Memcached help reduce the load on databases and speed up response times. Content delivery networks or CDNs are also used to deliver static content faster. Security and privacy concerns are paramount, especially when handling sensitive data. Large-scale systems implement encryption for both for data both in transit and at rest. They also use strong authentication and authorization protocols such as two-factor authentication to protect user data and ensure compliance with laws like GDPR. Let's move on to key design considerations. When building large-scale systems, we need to think about scalability, both vertical and horizontal. Modular design through microservices makes the system easier to maintain and scale. Event-driven architectures help ensure high throughput, and monitoring systems provide insight into the health of the system. Scalability is a major consideration. Vertical scaling involves adding more resources to a single server, while horizontal scaling involves adding more servers to distribute the load. Horizontal scaling is often preferred for large-scale systems as it allows for greater flexibility and redundancy. Modular design through microservices is another important consideration. Instead of building one monolithic system, we break it down into smaller, independent services. This makes it easier to develop, deploy, and scale. Google is a prime example of a company that uses microservices to handle its massive infrastructure. Caching plays a huge role in reducing load on databases. By storing frequently accessed data in memory, we can speed up response times and improve system performance. Redis and Memcached are popular caching tools used in large-scale systems. Event-driven architecture is another design consideration. In this model, services communicate asynchronously through events. This allows for better handling of high throughput scenarios like real-time notifications or messaging. Many systems, including social media platforms, use event-driven architecture to deliver updates quickly. Monitoring and observability are key to ensuring system health. By tracking metrics like response times, error rates, and resource utilization, we can detect problems early and ensure that the system runs smoothly. Tools like Prometheus, Grafana, and the ELK stack are commonly used for monitoring. Disaster recovery is all about ensuring that the system can recover quickly from failures. This involves maintaining data backups and implementing failover systems. Cloud services like AWS and Google Cloud provide disaster recovery options to ensure business continuity in case of system outages. Now let's look at an example of system design for Facebook. Facebook handles massive amounts of traffic every day, so it uses load balancing to distribute user requests across multiple servers. Data is stored across multiple locations using sharding and replication, and caching is used for quick access to user profiles and posts. The system is designed to handle real-time updates and notifications, ensuring a seamless user experience. In conclusion, building large-scale systems requires careful planning and consideration of factors like scalability, performance, security, and fault tolerance. The real-world example of Facebook highlights how these principles are applied to handle millions of users globally. By following these best practices, we can design systems that are robust, scalable, and efficient. That concludes the presentation. If you have any questions, feel free to ask. I will be happy to answer.